Hello students, let us continue with chapter 8 quadrilaterals. We will take a look at question number 3 of exercise 8.1. So we need to prove that if the diagonals of a quadrilateral bisect each other at right angles, then the given quadrilateral is a rhombus. So what I have done is drawn my quadrilateral ABCD such that diagonals AC and BD intersect at point O. So they are not just intersecting, but they are getting bisected at point O at perpendicular angles, which means OA is equal to OC and OB is equal to OD, as well as each of these angles at the center, that is angle AOD is equal to angle DOC is equal to angle COB is equal to angle BOA, which is 90 degrees, because the diagonals are getting bisected at O at perpendicular angles. So what do we need to prove? That quadrilateral ABCD is a rhombus. So in order to prove any quadrilateral as a rhombus, let's revise the definition of what your rhombus is. We have learned that rhombus is a parallelogram in which each side is equal. So what do we need to do is prove two things in order to prove that quadrilateral ABCD is a rhombus. What are those two things? First, to prove that quadrilateral ABCD is a parallelogram. Then the second thing that I need to prove is that AB is equal to BC is equal to CD is equal to DA. That means each side is equal. So what we will do is first go ahead and prove that my quadrilateral ABCD is a parallelogram. Let's come back to the definition of parallelogram. What do we know about parallelogram? That each pair of opposite sides are equal as well as parallel, or you can also prove that if a pair of opposite side is equal and parallel, any one pair of opposite side is equal and parallel, then the given quadrilateral is a parallelogram. So let us take these two triangles AOB and DOC. So I will take my triangles. We are going to erase these triangles, so I am doing it on this side of the board. So I have AOB and I have D, O and C. What has been given? That AO is equal to CO. Why? Because the diagonal AC is getting bisected at O. Also I have what? That OB is equal to OD. Why? Again BD is getting bisected at O. And each of this angle here AOB is equal to DOC. Therefore, the two triangles are congruent by SAS test of congruence, which is side, angle and side. Therefore, what can I say? That AB is equal to CD. Why? Corresponding pair of congruent triangles. Also, I can show that angle ABO here is congruent to angle CDO. Why? Corresponding pair of congruent triangles. So, therefore, now if you notice, these are a pair of alternate angles. Let's come back to our diagram and see. Angle ABO and angle OD and angle COD, they are a pair of alternate angles for lines AB and CD. Therefore, what can I say? That AB is parallel to CD. So, what have we proved? That AB is parallel to CD as well as AB is equal to CD. Therefore, I can say that my quadrilateral ABCD is a parallelogram. So, let us write this down first. I will say proof. In triangle AOB and triangle COD, I have OA is equal to OC and OB is equal to OD. Correct? Because AC and BD bisect at O. Also, I have angle AOB is equal to angle COD. Why? Each is 90 degrees. Since AC and BD bisect each other at bisect each other at right angles, right? So each one of these angles, as we discussed earlier, are 90 degrees. Therefore, what can I say? That triangle AOB is congruent to triangle COD by SAS test of congruence, which is also the side angle side test of congruence. Therefore, let's write, therefore, AB is equal to CD. I'll say corresponding pair of congruent triangles and I'll mark this as 1. Also, I have angle ABO is equal to angle CDO. Again, corresponding pair of congruent triangles. Now, let's come back to our ABO. So, ABO can be written as ABD because O lies on the line segment BD. So, instead of ABO, I am going to write ABD. Therefore, or I can say implies, let's mark this as 2. So, I will say 2 implies angle ABD is equal to angle. So, we have angle CDO now. Now, CDO can simply be written as CDB, correct? Because O lies on the line segment BD. I'll say 3. Or rather, now these two angles out here, if you see, they are forming a Z. That means this angle is equal to this angle, which means AB is parallel to DC. Therefore, AB is parallel to CD. I'll say alternate angle theorem. Correct? And let's mark this as 3. So, what do we get from 1 and 3? That quadrilateral ABCD is a parallelogram. And I'll say from 1 and 3. So, my first section out here is proved. Now, I need to prove that each of these sides AB, BC, CD and AD are equal to each other. So, let's go ahead and prove these sides equal to each other. So, what we are going to do now is I am going to take two triangles again. Which are my two triangles? Let's say I'll take triangle ABO and triangle CBO. So, let me draw my triangles over here for reference because we'll be needing that space. So, okay, there isn't much space here, so we'll do it there itself. And triangle CBO. So, I have ABO and CBO. So, what do we have? We have OA is equal to OC. Why? Because here if you notice that AC is getting bisected at point O. So, I have OA is equal to OC. Also, OB here is common for both the triangles, correct? So, this is congruent. Also, we have each of these angles as 90 degrees. Therefore, these two triangles are congruent again by the side angle side test of congruence. Therefore, what can I say? That AB is equal to BC through corresponding pair of congruent triangles. Let's write this, then I will tell you how to prove the other sides equal to each other. Okay. So, my second part starts here, and let's mark this statement as 4 because in order to prove that my quadrilateral is a rhombus, I will be needing both these points, which is why I have marked that conclusion that ABCD is a parallelogram as equation 4. So, my second part starts here now. In triangle ABO and triangle CBO, I have BO is equal to BO, common side. Then I have AB is equal to CB. Why? Sorry, AB is equal to CB is something we need to prove. I have OA is equal to OC. Why? Because AC is bisected at O, and I have angle BOA is equal to angle BOC because each is 90 degrees. Therefore, what can I say? That these two triangles are congruent by the side angle side test of congruence. So I am writing triangle ABO is congruent to triangle CBO by SAS test of congruence. Right? Now let's prove that AB is equal to CB. Therefore, AB is equal to CB by corresponding pair of congruent triangles, and let's mark this as 5. So now I have taken my two triangles ABO and CBO. What if I take these two triangles now, CBO and CDO? Again I can prove them congruent by the same test of congruence, that is side angle side test. Let's just look over here. We are not going to prove it again using the same wordings, but I will show you how you can similarly prove these two triangles congruent. So I have CBO. So this is C, B, D, O. Now BD is getting bisected at O, therefore these two are equal to each other. Also I have this as the common side, and these both are right angles. Therefore CBO is equal to CDO, again by side angle side test of congruence. So what can I say? Similarly we can prove that, and therefore once these two triangles are proved congruent, I can say that CD is equal to CB, correct, by corresponding pair of congruent triangles. So let's just write similarly we can prove that CB is equal to CD. Let's mark this statement as 6. So we have proved AB is equal to CB using these two triangles. We have missed out something over here, BOA and BOC. Okay. Now if you notice 5 and 6, you have AB is equal to CB, and in 6 you have CB is equal to CD. Therefore what can I say? That AB is equal to CB is equal to CD. So the last thing that we need to prove is that these three sides we have already proved, you can say by using 5 and 6, the three sides AB, CB and CD are equal. Now we need to prove this side, that is AD equal to any of these sides. So let's say I am going to keep this triangle CDO itself, and I will take my triangle ADO. So I have ADO. So if you notice now, these two triangles can also be proved congruent by the same side angle side test of congruence. Why? Because if you notice, OD is the common side, right? Each angle is a right angle, and AC is getting bisected at O. Therefore these two triangles are congruent by the side angle side test of congruence, and I have AD is equal to DC. AD is equal to DC. So I can similarly say, we can prove. So how do we prove that AD is equal to DC? By corresponding pair of congruent triangles, for congruent triangles AOD and COD. Similarly we can prove that CD is equal to AD. Let's mark this as 7. So what do we get from 5, 6 and 7? I get that AB is equal to BC is equal to CD is equal to AD. So I'll say AB is equal to, we have CB which we can write as BC. If you want, we'll write it as CB first and then change it to BC, because CB and BC are the same sides. CB and BC are the same sides. So let's just write what we have proved, and then we'll shuffle it according to our requirement. So I'll say AB is equal to CB is equal to CD is equal to AD, and I'll say from 5, 6 and 7. What is the requirement? AB is equal to BC is equal to CD, which is equal to DA. So I'm keeping AB as it is, I'm rewriting BC, I'm keeping CD as it is, and I'm rewriting AD as DA. Correct? Therefore, and I'll mark this statement as 8. Now I'm going to go back to my first section's proof, which was that ABCD, quadrilateral ABCD is a parallelogram. So I'm going to take my point number 4 and my point number 8 in order to prove that quadrilateral ABCD is a rhombus. So I'll say therefore quadrilateral ABCD is a rhombus, and I'll say from 4 and 8. Hence proved. So just a quick review what we did. We earlier proved that that quadrilateral ABCD is a parallelogram by taking these two triangles AOB and COD, right? And then we proved that each of these triangles are equal to each other by taking triangle AOB and BOC, or AOB and COB. We proved these two sides equal. Then we took these two triangles over here and proved these two sides equal. Again we took this triangle and proved these two sides equal to each other. Therefore all the sides are equal, and since ABCD is a parallelogram and all the sides are equal to each other, we have that quadrilateral ABCD is a rhombus. So this was about question number 3. We will take a look at question 4 and the other topics in the forthcoming videos.
Hope this video increased your knowledge. For more such videos and a completely free educational content, log on to www.epathshala.org or visit our ePathshala YouTube channel. We have each and every question solved for maths, physics, chemistry and biology. So subscribe our channel, share with your friends, like our Facebook page and follow our Twitter handle for regular updates and important educational tips, and also win ePathshala goodies. So what are you waiting for? Subscribe this channel and enjoy the freedom of education.